Hello, welcome back. A recap of our inference, right? So we have spent chapter 8, chapter 9, chapter 10, and chapter 11. We've spent 4 chapters looking at inference procedures. Okay? And in each of the following settings, I want you to state which specific inference procedure you should use. For example, a 2-sample z-test for a difference in proportions. And I want you to provide reasoning. You do not need to carry out any procedures. Okay? What's our first setup? What is the average voter turnout during an election? A random sample of 38 cities was asked to report the percent of registered voters who actually voted in the most recent election. Okay. What do you think would be the correct procedure, inference procedure to use here? Well, if you answered a 1-sample t-test for mu, you are correct, where mu is the average voter turnout rate. Single sample, our sample size, n equals 38. 38 cities. T-test, we do not know sigma. And, keyword, the average of voter turnout. Right? This could have even said proportion in the problem. Said what is the average voter turnout proportion during an election? Guess what? It's still an average. Right? We can have an average of proportions. That's fine. Think of your test grades and your homework grades and your grade at the end of 6 weeks, right? That's a proportion. How much you've been doing correctly out of how many possible things you can do. And you say, oh, but it's my average grade. Okay. The reasoning, well, mu is the average voter turnout rate. N is 38. Sigma is not known, so we have 1 sample t-test for mu. Okay. What about the next? Are blondes more likely to have regular dates than the rest of the single world? Independent random samples of 300 blondes and 300 non-blondes were asked whether they have regular dates. What inference procedure would we carry out here? Think about it. Well, for this particular situation, if you answered a 2-sample z-test for a difference in proportions, you would be correct. If you answered a chi-square test for homogeneity, you could also be correct. Why would we say 2-sample z-test for a difference in proportions? Because we have more than 1 sample. We have 2 samples. And in fact, we have 2 groups to look at proportion comparison. Okay. Now, in this piece, right, notice that we asked 2 different samples. So we controlled for having blondes and having non-blondes, and asked about regular dates. So that's where a chi-square test for homogeneity could also come into place, right? Because we controlled for hair color and want to see if distribution are different. Right? Is the distribution of dates for blondes different from the distribution of dates for non-blondes? So this is a nice situation where you have 2 different possibilities. If this was multiple choice, you'd want to read very carefully about whether they are specifically asking about the proportions or they are specifically asking about the distributions. Here it just says, are blondes more likely? Well, that could be a proportion or it could be a distribution. Okay? Very important question. Hopefully you have a better understanding of what's happening.